So what we have here is geotrig lesson 8. We're going to start part A. This will be day 1. What we're going to do is talk about today is statements of similarity. This is actually something we touched upon once already back in possibly lesson 2 or 3. Because we started talking about what does it mean to be similar triangles. You guys remember that?
Yes.
And we said that, hey, if you're going to be similar to another object, you had to have a likeness. That likeness meant that all of the angles are the same. You can have a different size, but the shapeness will always be there. Okay? Now, there's something really cool about similar things, and especially with similar triangles. We're going to study a lot of this here with triangles. And we know that if you could ever get to the point that you say that two angles in a triangle are the same, then the what? If two angles are the same, it implies all three. So all three are the same. So if all three angles are the same, that's how you show that they are similar. And if they're similar, I can state something about them. I can state a statement of similarity. I can kind of write it. I can state that this triangle is similar to that triangle. And so, we got some words here. It says, when using vertices, you know, the angles, right, A, B, C, F, E, D, are used of the triangles to write statements of triangle similarity, we must be careful. This is important. That you use the angles in the triangles that are corresponding. So what I said with A, B, C and F, E, D, they may be similar triangles, but I don't know if I can necessarily say that the triangle ABC is similar to triangle FED. The triangles themselves, sure, they're going to be similar. I think we can look at that. We'll talk about that in a second. But that statement would actually be false. Because I'm going to list them as ABC, or ACB, or CAB, or BAC, or BCA. There's like 6 different ways. I can state the left triangle. That means there are 6 different ways that I can state the right triangle. They need to correspond. I need to go in the same order. And that order has to be of their angles. Now, I think everybody should agree that those are right triangles. You guys agree with that? So, these very well could be 30, 60, 90 triangles, yeah? They may not be drawn to scale, but they could be. So, if I wanted to, I could state this triangle's 30, 60, 90, that particular order. I would have to name the 30-degree angle, the 60-degree angle, and then the 90. That can be similar, but it would only be similar to this triangle in the exact same order of angle size. 30, then 60, then 90. I need to list corresponding angles in the same order. So, right here, it says these triangles are similar. They're similar because, look, they share a 90. We already talked about that. And look, they also share a single tick band, right?
Right.
And if 2 are the same, that implies
That means they're all the same.
all the same. So we also can have a double tick mark in there. So all 3 angles are the same. Yay. That means these are corresponding. That means they also have a scale factor between them, yeah? Now, here's a cool thing. That because they're similar, we can use a certain symbol. It's actually written on the page already. And that symbol just kind of looks like a curve, like this. And that symbol is what we're going to use for similar. These 2 triangles are similar. And so, as we have it stated in the bottom left-hand corner, triangle ABC similar to triangle blank, blank, blank. Now this is where it's very important. It's very important that you have the order correct. A is what angle in the left triangle? It's the right angle. So therefore I need to go over here and hunt for the right angle. That's letter D. So D. I'm then going to go to B. B was the single tick mark, which corresponds to E. And C is the double is F. So the proper way to state this, or one of the proper ways to state this, is that triangle ABC is similar to triangle DEF. Is that the only way? No. Could I have switched the letters on the left? Could I have gone CBA?
Yes.
So triangle, let's try that. Triangle CBA would be similar to triangle FED, which we're all hoping to be after school. So, you guys see how if I change one triangle's angles, I have to also change the other one.
Yep.
That's a pretty simple topic, right? Simple idea?
Yeah.
Universal idea. Corresponding angles should be listed the same way. It's kind of like, if we, I guess this is a good analogy, in real life. If we were all going to come up with this idea to collect data on people, maybe their height, their age, and where they live. Like what city they're born in. Wouldn't it be really easy then if we all decided to go, okay, what we're going to do is the first column we're going to put their age, the second column we'll put their height, and the third column we'll put the city they were born. Because that way we can go in and we can just gather all the data together real quickly, right? We can compare apples for apples that way. Versus one person makes the first column their name, the second one, person comes in and makes the first one their height instead. Well, that's kind of hard to really just quickly put things together. Am I good with this slide? You guys good?
Yep.
Okay. The second thing, why is it important? Not only, like I just said, makes things efficient, I can quickly determine. Actually, let me go back real quick. Would you guys agree that this triangle right here, I can't just rotate it? Like if I try pushing this triangle angle this way, E is up here, and then what? D goes over here, and F goes over here. Is that got the same orientation as this one? No. I don't think I could actually move this one just by rotating it to be the same. I would have to flip it, right? D, F, and then E up top, right? But now, A, D, B, E, C, F. Because obviously we go here and put in our tick marks, right? So I could flip it. It allows, it's just another way for us to identify and kind of orientate, if that's the right word to say it, things the right way, nice way. Okay, let's go back to this one. So that's kind of important. Then a second important thing is, you guys remember back to that scale factor idea? This triangle has a scale factor of 2 compared to that one, as in one's twice the size of the other one. We did that by looking at corresponding sides. Now, let's think of this for a second. We had two triangles. We had triangles A, B, C, and when we rotated it, triangle D, E, F. Yes?
Yeah.
Okay, you guys probably have them on the same side. You don't need to rewrite them. Watch what happens. If I wanted to find that scale factor, I would have to look at side opposite A. Would you guys agree? This would be little a. Well, they don't have little a listed, do they?
No.
So instead, I'm going to name that using my line segment idea. It has endpoints B, C. So could I say, I'm going to write this down here. So BC is to opposite A, so that has to be opposite D, right? Which would be EF equals, pick a different one. Let's do opposite B, which would be AC over equals the same ratio of sides, opposite C, which is AB, over DE. Does everybody understand where I got the ratios from? We said they were similar triangles. And if they're similar triangles, then their ratios of corresponding sides are all the same. You would have a 1/2, a 1/2, a 1/2 if we had numbers there. That takes a long time to set your triangles up, rotate them the right way. What if it didn't even give me triangles? Watch this. Let's go back up to this guy right here. See this? Hey, look, there's our statement again, isn't it? Didn't we state that? Watch this. You guys watching?
I think so.
A, B is to D, E. Which letters are right next to each other? Look at that. The first two letters of the first one over the first two letters of the second one. Equals. Hey, look at this. BC over EF. Equals, and then I'm going to connect the A and the C to the DF. Now, it's not the exact same order, is it? But they are all still equal and they are the same. AC, DF is in the middle here. There it is. BC, EF, boom. And AB, DE is there. Isn't that cool?
Yeah.
And if by chance I took any of these factors, or all three really, and I flipped them and they're all reciprocal, then I'm just talking about putting DEF on top of ABC. I'm comparing from right to left instead of left to right. That's the power of the statement. I don't even need the triangles there to make it true. Okay? Any questions?
No.
That seems pretty straightforward, right?
Yeah.
So, look at your next problem. The next problem, it says, you have a triangle ABC. That's the big one. Line segment BD is an altitude to the hypotenuse, aka the largest side, AC. Show that AD over AB is equal to AB over AC. We've done problems just like this in our homework in the past. We had to find the scale factor to solve for like X, Y, and Z. Yeah, you guys remember that, don't you? How many triangles were actually in this one triangle? There are 3, aren't there? So, what we can do then is I only want to show this ratio. So I'm going to go back to this guy. I am going to find the two triangles that are similar so I can write a statement, figure out if the statement gives me this. Now, the tops are one triangle, the bottoms are the other triangle. Right? AB, BC, AC were all of the left triangle sides. And all the bottoms here were the left, or the right side, sorry. So, AD and AB. Where is AD and AB? AD is here, and AB is there. So I think I'm talking about this triangle, that smaller one, right? So can I write that? A, D, B. If there's one thing I know, it's a right triangle. Why? Hey, if this is a straight line, and this guy drops straight down at a 90, that means both sides have to be a 90. Okay. Now, next one. I need to know where AB and AC are. Who's got AB and AC? There's AB. Where's AC? The whole entire bottom. So which triangle are we talking about? The super big one, right?
Yeah.
I'm not even going to try to fix it. I'm going to leave it as A, B, and C. I'm not even going to rotate. I don't need to. I know that that is a 90-degree angle up top because it shows that in the diagram. So it might be a little hard to see on the screen here, but can you see the box up there?
Oh, yeah.
Do we have enough information to state these are similar?
Yeah.
Wow. It takes 3 angles to say they're similar. I only see 90s. What angles are the same?
B and D.
B and D.
Or, yeah, D and D.
D and D. No, D is not even in the second triangle.
B and B,
Confused what we're talking.
right?
Right? I need to figure out. I got no D and B. Yes. Okay. Sorry. D and B are the same because they're both 90s. Is there another one? Because if we can find another one, then we can claim all 3. Why B and C? That B right here? And that C? Why? That's probably not the one that I would go with.
A.
Why A?
That's the same angle.
Well, they have the same. Guys, where did the small triangle come from?
Big one.
From the big one, but on the left side?
Yeah.
Isn't that A the exact same A as the big one?
Oh, yeah.
So therefore, this angle and that angle are the same. If 2 angles are the same, it implies all 3 are the same. You now have tick marks where now you can make your statement. There are 6 different ways to write this statement. Someone with the left triangle start us off. Triangle what? A, B, D. Okay? A, B, D. You now have a road map. You need to follow that same map. Why is it not leading up there? Okay, so let's fix this problem. Now we got the glitch taken care of. So, triangle ABD is going to be similar to angle A, which is corresponds to the single tick band, which is also A. Then B, which is corresponding to C, and then D corresponds to the 90, which is back to B. This allows us to set up our statements of similarity so that way we can write our ratios. And so to do this, to show, to do the showing here, I'm just going to use my statements to create the whole statement or the ratios, and then I'll show or see that they are equivalent. So, look at this. AB is to AC is equal to BD is to CB is equal to AD over AB. And if I look at my ratios, I want AD over AB. Hey, there it is. I also want AB over AC. There it is. Now remember, if the outside, this is equal to that, and the other side is equal to the middle, that means that So by the transitive property, that means the outsides have to be equal. So I can state AB over AC is equal to AD over AB, just the reverse order. So therefore, I have shown that the ratios are the same. Have a great day.